The second question is, it is suggested that the following functions of v. Function A is fv equals to e to the minus absolute value of v. B, the function of b is fv equals to sine v to the 2 over v squared. There's function c is fv equals to 1 when the absolute value of v is less than alpha, and 0 otherwise, may represent an autocorrelation function of a stationary stochastic process by setting v equals to tau, or a spectral density function by setting v equals to omega or both. Which functions fv may represent either or both? Explain your answers. For the first function a, we need to prove it is even and the r tau is less than r0, and its Fourier transform is non-negative. And as omega is a power of spectrum, and it must be non-negative. So the first part, we need to prove that when it is an autocorrelation function, it is even, and when v equals to 0, it is the largest, and the power spectrum is non-negative. So because it's absolute value, so it's even. Since it's when the upper part is less than 0, it usually goes smaller. So 0 is largest, and we can see that the Fourier transform is 2 alpha over alpha to 2 plus omega to 2, which is non-negative, so it can represent. And when e to the minus the absolute value of omega is also even and non-negative, so it can represent. And this one, so we can also use the same method to prove that it's even and it is largest when tau equals to or limited to 0, and you can see the Fourier transform, it is even and non-negative, so it can represent an autocorrelation. And it also can represent a power spectrum because it is equal or larger than 0. You can see that it can now represent the autocorrelation function since the Fourier transform is non-negative, and it can represent the spectrum function.